So as a vibration of sound travels through a medium, they are picked up by the receiver or a detector that is in the same medium. These receivers can be in a device like a decibel meter, right? Or in the human or other animal. Okay. Every receiver has a special part that pick up and identifies the exact or vibration it encounters. Okay, so every receiver has a own component, has a own, you can say, have a special part for absorbing. For example, you have your hands. Hands cannot absorb your vibration of sounds, right? You have the special part which is air, right? Similarly, every instrument or every thing who is receiving the sound, they have a special part. So in human beings, we hear sound through our ears. Okay. So this, the receiver of the sound in human is the ear. So it's our ear. The human ear includes an eardrum, which is a thin membrane-like stretched rubber sheet that help us to sense different vibration. The process of hearing in humans can be summarized as follows. So first is the vibration from the medium enters the ear canal. Okay. Then it passes through the ear canal. Okay. They pass through the ear canal and reach the eardrum. And then the eardrum vibrates in a similar way to these vibration and passes through the inner ear. The inner ear converts this vibration into signals and send them to the brain. Okay, so this is the process how human beings, get the sound. But over here, when someone will ask you how, sound get received, so you will mention that sound get received at the people or maybe anything who is receiving the sound, they have a special part for it. So you will write this one. You will write reception of sound in this paragraph, and after that you will write hashtag we hear sound through our ears. Okay, then you will write this process. Okay, you will first write the receiver of sounds in human is air, right? And then you will write this. The vibration from the mental vibration this. Okay, this is the process. Yeah, and this is the human ear. You can see. Okay, so in which part vibrates when we hear the sound? Of course, you need a part that will vibrate and then you will hear. So eardrum basically vibrates, and because of that only you hear the sound. Clear? Oh yes. So first write reception of sound, then this, and then next.
Mom, what I have to write?
You have to write reception of sound and this paragraph.
So I have to write the.
Yes, you have to write the entire paragraph.
As the vibration of sound travel, should I write that?
Yes, sir.
Okay, ma'am. Ma'am, can you scroll down? Ma'am, I have to write the entire para.
No, Swar. You have to write hashtag we hear sound through our ear. Okay. Then the receiver of the sound in humans is the ear, and after first, second, third, fourth.
Okay, ma'am. Ma'am, finished.
Okay. Now coming to next one, which is okay. Now coming to amplitude, time period, and the frequency of a vibration. Okay, these are the three terms: amplitude, time period, and frequency. So let's just first do this. See, we have seen the sound are produced and at a source due to vibration, right? So these vibration are to and fro. To and fro means from this to this, to and fro motions, also known as oscillation. Okay, so this is known as oscillation. So the vibration which go from one end to other, and you what you will say that they are oscillating. Okay, when these vibrations change, the sound produced change too. Vibration differ in two key properties as well. So vibration can be different. Okay. So there are two things. One is your amplitude and one is your frequency. Okay. So ma'am, what is this? So the maximum distance traveled by vibrating particles from its mean, which means rest position. Okay, that is known as amplitude. Okay, the number of times the object or the surface vibrate in 1 second, that is frequency. Getting the point? It is, for example, this is the object and this is object 2. So this is basically the distance it is covering. This is amplitude. Okay, but in 1 second, right, in 1 second, how many number of times the object is vibrating? Right, maybe vibration is like this. So in 1 second, how many vibration it is completing? That is frequency. Clear? Now, because of amplitude, what you determine, you determine loudness. The greater the amplitude, the louder the sound, right? So it is like if its range is high, then of course it is too loud. Then what frequency determine? Frequency determine the pitch or the shrillness. Sometimes the person who is shouting, you feel like it's somewhere shrilling your ears, right? You feel like, oh my god, it's so rough voice, right? So that is shrillness. The greater the frequency, the higher the pitch, that means higher the shrillness of that particular person or particular sound will be. Clear? And now the third was time period. So ma'am, what is time period? The time period is the time taken for one vibration. It is reciprocal of the frequency measured in seconds. Right? So time period is basically how much time one vibration is taking from reaching one point to another. That is your time period. How much time you took. Right? So amplitude and frequency of vibration produce vary the sound produced, and what we hear changes, right? So as you know that there are three things. One is frequency, vibration, and this frequency, amplitude, and time period. Right? Time period cannot determine anything because it's usually the time, right? But frequency and this amplitude determine a lot. What they determine? They determine like how the sound will be produces and what we hear change, right? If frequency is high, low, it also affects what you will hear. If your amplitude is high or low, it also affects what you will hear. Clear? So this is what. So what you will write? You will first write this amplitude, time period, frequency of a vibration. Then you will write this. Sounds are produced as a source due to vibration. These vibrations are to and fro motions known as oscillation. Okay. And then you will write amplitude and frequency. Then these two. Then you will write time period. Then this, and then you will write till here. Here. So first you will write the give you.
Should I differentiate between frequency and amplitude?
Yes.
Ma'am, so I have to start from sounds are produced, not we have seen that.
Yeah, you don't have to write. Just write oscillation, and after that, write this definition.
Okay, ma'am.
Yeah. And after that, write differentiate between amplitude and frequency. Then these two, and then write time period. Then the definition of time period, right? And then last point will be this amplitude and frequency. This clear?
Ma'am.
Yes. So we're in maths. Which chapter you have started?
Playing with numbers.
Oh.
In maths, we haven't completed much because we did most of we took most of time for revision. In science, ma'am started revision from yesterday, so we finished 2 chapters.
Okay. So that's good for us. We can do maths.
Ma'am, in the definition of time period, should I write it is the reciprocal of frequency measured in seconds? I should write that.
You have to write this. Time period is a time taken for one vibration, and then it is a receiver.
Okay, so I have to write the it is the reciprocal of frequency and all that.
Yes.
Ma'am, what is that formula? Time is equal to 1 upon frequency.
Yes.
Ma'am, I've written it.
Okay. Now coming to next one, which is loudness and the pitch. Okay. Over here we discuss louder the sound and the pitch. So what is this basically? See, the loudness of a sound is determined by the amplitude of the vibration. Loudness of the sound is in fact the proportion to the square of amplitude of vibration. It is measured using a unit called decibel. So loudness is always measured in decibel. The higher the decibel value, the louder will be the sound produced. Okay, you can see this, right? So it is like over here it's zero. Rustling of leaves, you never hear them. Refrigerator, this rainfall and all that. But you can say firework, jet engine, they have this 130 dB. So higher will be your decibel, higher will be the sound, louder will be the sound. Okay. Then now coming to pitch. A pitch or a shrillness of a sound is determined by the frequency of the vibration. It is measured using unit called hertz, right? Hz, the number of vibration per second. So what is hertz? Basically the number of vibration per second. So see, instrument, drums, like instrument and oscillation per second in frequency. So drums, oscillation is less, so your frequency is low. But trumpet, at the same time, their oscillation is more, so they have higher frequency, right? This. So first you will write this too. What you will write hashtag loudness and pitch. First write hashtag loudness and then write this paragraph. Then after hashtag pitch and write this. You have to remember over here first how loudness is determined, how pitch is determined, plus what are the unit that in which you are going to measure pitch and loudness. Clear?
Okay. So I have to start from the loudness of pitch to the sound produced. That's it. Right?
Yes.
I'm finished writing.
Now you will write pitch.
The entire 2 lines.
Yes.
Okay. Ma'am.
Yes, Swar.
Ma'am, can you scroll down?
That's it for today. That's it for today, na? That's it for this. Not for today, Swar. Okay, so let's just start. Next topic.
Ma'am.
Actually, I was about to say that's it for pitch, but I said that's it for today.
Ma'am.
Okay, now it's like next question is audible and inaudible sounds. Okay, so we have learned that sound vary with frequency, right? The human ear can only sense sound with a certain range of frequency. This is called the audible frequency range in human. Okay, this range is between 20 hertz to 20,000 hertz, right? Very important. Hertz, you already know how we the pitch one, right? So if the answer is like if the range is between 20 hertz to 20,000 hertz, or you can write 20 kilohertz. Instead of writing 20 hertz, you can 20,000 hertz, you can write 20 kilohertz, right? Because in one kilohertz, it's 1 hertz, it's 1 kilohertz, it's 1,000 hertz. Okay, so it is basically if it is in between, you will able to hear it. But if it is less than 20 hertz or more than 20,000 hertz, you won't be able to hear them. Okay, so you can see this 7,000 to 20 hertz, it's for bat. Very important. You will make it like this. 1,000 to 70,000 is basically the mouse, or you can say 64 to 46, it's the wolf dogs. And 48 to 75, it's this. And then 20 to 20 hertz is this. And 14 to 12 is basically the elephants and all that. Okay. So less than 20 is basically the elephants. And more than 20,000 are basically the bats, mouse, you can say dogs and cat. Clear?
Ma'am,
You will
14 to 12,000 means 14,000 to 12,000 or 14?
14,000 to 12,000.
Okay, then that means 20,000 to 20,000 hertz. How is that possible?
This is sorry.
Ma'am, if it is 14,000 to 12,000 hertz, then how it is 20,000 to 20,000 hertz? How does it make sense?
I'm just saying it's 14 from 12,000 till 14 to 12,000, and then
Oh,
20 to 20,000, 20 to 20,000. Okay,
okay,
14 to
ma'am.
12,000. Okay.
Okay, ma'am. Ma'am.
Yes. Okay, that's it for today. If you will write this down after that.
Ma'am, but what do I have to write? You're covering it.
No, you have to write this audible and inaudible sound.
That's and then
Then you will
again.
write this. The human ear can only sense sound this and this. See, if it is in between, it is called audible. If it is less than or more than this, then it is inaudible. Okay?
Ma'am, so can you just technically just mark out what I have to write?
Yeah, I have already marked.
Okay, the entire paragraph from the human ear.
Yes. Swar, for tomorrow, I will keep your class from 3:15 to 4:15. Okay?
Okay. Ma'am, since anyways, my mother is not going to allow me to go to TT coaching. Are you free from 4 to 5?
I am not available from 4 to 5. I can take your class from 5 to 6 if you want.
5 to 6. Oh,
Because from 4:15, from 4:15 to 5, I am busy with some work. That's why.
okay, ma'am, 5 to 6. Because 3:15 will be too early.
Okay. So 5 to 6 will be taking your class. Okay?
Yes, ma'am. Ma'am,
Yes. Yes. You were saying something?
no, ma'am. Ma'am.
Oh.
I'm done. Goodbye, ma'am.
Sir, after this, you have to do this as well.
No.
You will write first this. The hearing range can vary greatly across different living beings, unlike this. Okay? Hmm?
Ma'am, I made it.